This is our Lunabotic CDR by Joey Mebo and Zachary Renault. First off, we have ConOps. Our first step is going to be to navigate through the slalom as quickly and as safely as possible so as not to lose points by knocking the balls off. We will then perform a 180-degree turn before maneuvering around the final ball as required. We will then enter the collection zone backwards. We will lower the box and begin pushing the balls up against the wall to allow for easier scooping. We will then scoop the 4 practice balls and exit the collection zone. Navigate over the ramp safely so as not to lose any of the balls we just collected, and we will deposit the golf balls into the bucket. Our desired outcome is to navigate the slalom in less than 30 seconds. We will then acquire and deliver the balls in no more than 1 minute and 10 seconds after completing the slalom. We will then navigate through the entire slalom one more time after delivering the balls. We will then acquire another 4 total practice balls. So ideally, we would like to acquire 26 total points for our run, 10 points coming from the slalom, and another 16 from acquiring and dropping off the balls.
The compiled design combines the drivetrain, ball collection, storage, and release. As you can see, we have isometric views at different angles of the robot. The bottom right picture has the ball collection box. We were not able to get that in the stud.io renderer because it's a cardboard box and they don't have a model for that. The first subsystem we'll talk about is the drivetrain. The drivetrain has 2 powered wheels. Additionally, it has skis meant for omnidirectional movement. We elected to invert the brain of the EV3 to keep the center of gravity as low as possible. Additionally, the short wheelbase allows us to execute tight corners.
The next subsystem we'll talk about is the ball collection, storage, and release subsystem. This comprised of 3 main parts, the first of which being a track, which allows us to raise and lower the box for easy scooping as well as delivering of the practice balls. The second part is the mounting system, which essentially pinches the box in between 2 pieces to allow for stability and ease of maneuverability for the box along the track. The final piece is the box itself, which allows for the storage of the golf balls. This box contains a small ramp on the edge to make depositing the golf balls significantly easier.
The next subsystem we'll talk about is the user inputs. The app provided by the LEGO company turned out to be quite glitchy and sometimes even unresponsive on certain phones. The second app we found, called Remote EV3, is able to deliver fine analog commands to the robot with a simple and large interface. Our most pressing challenge was the third point of stability for the robot. 2 wheels are powered, and a third must be able to move in any direction. Of the 5 ideas we tried, the long curved lift arms for skis had the least amount of friction and were the best decision for our robot. Additionally, the collection container had low capacity when we started out. It was also quite unstable. To fix this, we installed stabilizers towards the bottom of the box, and we also installed cross-tensioned 1x9 lift arms to interface with the cardboard box so that it could squeeze tightly and we didn't have to use any tape or glue.
These are some of our prototypes for the skis. Our design that we settled upon is quite similar, however, a little more simplified and creates a lot less friction while being just as stable.
These are the citations we used while conducting our project. The first is from the Remote ED3 app. Second is the stud.io rendering software. And the third is the Mindstorms Commander app. Thank you.